Hi everyone, I'm getting ready to record our next video. And this one is going to be on, sorry, let me just hide this. There we go. So we're working our way through Unit 2, Chapters 3 and 4 on quadratic functions. And I'm taking a look at 3.3 in this video, where we're looking at completing the square. The objective is to help you understand how to rewrite the standard form of a quadratic function into the vertex form using the method we call completing the square. In terms of vocabulary, make sure that by the time you've finished going through this video that you understand really clearly what perfect squares are, what completing the square means. Now, let's just go quickly through what we have covered to this point. What is the vertex form of a quadratic function? Well, we know that the vertex form is the form that we can rearrange the elements of the quadratic function so that we're able to see what the vertex is very quickly. We have a out in front. We have what's called a perfect square. And inside the perfect square is the value for the x part of the vertex. We change the sign. And then the y part is the number that sits on the end. Secondly, what is the standard form of a quadratic equation or function? This is where we put all the ducks in a row, so to speak. So we go from ax squared to bx to c in descending order of the exponents that you see in the variables. And this one is a very orderly one, very tidy one. As we say, everything is in its place. So the question really is, how do I rearrange the standard form so that it looks like the vertex form and I'm able to find my vertex pretty easily? In order to understand the method we're going to learn in this video, let's review perfect squares for a moment. Now, when we talk about perfect squares are any number that we multiply by itself. 4 times 4 is a perfect square, so the number 16. 5 times 5, 25, is a perfect square. And we can also have algebraic expressions like x plus 3 squared and x minus 3 squared. Now, if we were actually to multiply these out, we would have to FOIL them and then combine like terms. We would end up with x squared plus 6x plus 9. If we did the same thing for this one, we would have x squared minus 6x plus 9. So the question is there a pattern there that would help you actually expand this perfect square without going through the process of first foiling and then collecting like terms? And the answer is yes. It's a very easy one. To find the first term, you simply square this guy. The last one, you square this one. And the middle term is this times this 2 times. That's where the 6x came from, or the minus 6x. Well, once you see that, then it's kind of fun to go the other direction. And let me give you something that is a perfect square and ask you where it came from. So with this one, if you stop and consider it, and please do stop the video and try it yourself, but it comes from x plus 4 squared, whereas this one comes from x minus 5 squared. So seeing this pattern is going to help us with this process that we call creating a perfect square. We're going to try to find the magic number that will make a quadratic equation a perfect square. So, in an example like this one, I have x squared minus 10x, and I'm missing that last number. What is the number that I would need to place there to make this a perfect square? Please stop the video again and think about it yourself. Based on the patterns you saw, even if it takes you a couple minutes, try to sort it out. The answer is 25. And the way in which we find this is that we take this number in front of the x, which we call b usually, and we divide it by 2 and we square it. So the pattern or the formula that we use is b divided by 2 squared. So let's try a couple more and see if you can find the number to complete the square. All right, so with this one, we take the b divided by 2, which is -7, and square it. That's 49. And if we think about where this came from, this would have been x minus 7 squared. This one divided by 2 and squaring, we're going to add 81, and this one would be x plus 9 squared. This one's a little bit trickier because it's going to be a fraction, but don't let that throw you off. You're going to take this minus 5 and divide it by 2, which is a fraction, and you square that, you'll get 25 over 4. And this one came from x minus 5 over 2 all squared. So now that you've kind of played around with this pattern a little bit, you're ready to do this process that we call the completing the square, which allows us to take the standard form and move it to look like the vertex form. So we're going to start with a quadratic function. It looks like this one. And here's the process. Okay, the first thing that I do is I take the x squared and the x term and I put them in a bracket by themselves, keeping the 5 outside. And then I consider for a moment what would be the number that would make this a perfect square. So I divide this by 2 and square it. Turns out it's 16. Now I'm going to add that 16, but clearly I can't just do that randomly to an equation. So I turn around and subtract it. But because I don't want it inside this bracket, otherwise it's no longer a perfect square, I'm going to throw it outside. And I just have to remember that if there were a number sitting out in front, I'm going to have to multiply. As it turns out, this a was only a 1 and we didn't have to worry about it. So it throws out becomes minus 16. Now, this guy comes from x minus 4 all squared, and putting this together, it's a negative 11. So that gives me a vertex of 4 and negative 11. And we'll just keep on going through the next couple of samples. All right, so once again, gather these two terms, put them in a bracket. Look for the number that completes the square. Divide by 2 and square it. Plus 9, add it and subtract it. One thing I didn't mention again was the a was just a 1, so we didn't really have to worry about anything. So when we throw this out, we're only going to multiply it by the 1 that's sitting there. And so when we put those numbers together, I get minus 4. And this guy came from x plus 3 all squared. So my vertex is minus 3 minus 4. Now, we finally have one where there is an a. This gives us another step. First of all, we know that a, if we think about the vertex form, it has to come out front. So we pull it out, pulling it away from these two terms. And that leaves us with x squared minus 4x. And then we close our bracket and leave our 9 on the outside. Now, look for the number that makes this a perfect square. Divide by 2 and square it. Add that number and subtract it. And we're going to throw the negative number outside, but recall that it must be multiplied by the 3 that's there. So when you move it outside, it becomes negative 12. So let's just clean things up. This came from x minus 2 squared, and this is a minus 21. So my vertex is 2 and negative 21. Okay, let's try this one as well. This one is missing a number on the end, but no fear. We're going to be able to take care of it. Let's pull out that minus 5, leaves us with x squared minus 14x. We would need a 49, so we add it and subtract it. We're going to throw this out. And remember, when you do, you've got to multiply it by the negative 5 that's out front. So we're going to add, it will be plus 245 when we simplify it fully. And this one came from x minus 7 all squared. So my vertex is 7, 245. Okay, once again. Now, the difference with this one, we're pulling out a 4 from the first two terms. Leave your minus 23 outside. And the difference with this one is it's a fraction. I just wanted you to get it a try at one where there's a fraction. So you divide by 2, so negative 7 over 2, and square it is 49 over 4. Of course, we're going to throw the negative 1 outside, but not before we multiply it by the 4, and thankfully these guys cancel. So it's really just negative 49 outside. And so let's clean it up. This guy came from x minus 7 over 2. Oops, this should have a squared. That's an omission. Make sure you don't forget that. I do see that a lot, to forget it. And then putting this together, it's minus 72. My vertex would be 7 over 2, negative 72. Okay, so to finish off the video, we're going to take a look at a very particular style of word problem. We're going to be looking at a scenario where a student council is trying to raise some money. So they're going to hire a professional photographer, and people are going to make bookings to come and just have their picture taken with their best friend or whatever. The student council is organizing a fundraising event with a professional photographer. Last year, they charged $10 for the photo session, and 400 sessions were booked. They estimate for every $1 increase in price, they will have 20 fewer sessions booked. So we're going to try to create a function that describes this. We're going to talk about revenue, basically the cost of the ticket times the number of sessions, or the cost of the session, I suppose, times the number of sessions. Now, we know that last year they charged $10 and they sold 400. And what we know is that for every change of a dollar, and we're letting X be the increments of change, we know that for every $1 increase, we lose 20 bookings. So we've got the hard sort of part of this process done. The rest of it should just kick in as automatic. We're going to FOIL this. You'll see that I have FOILed it in all these terms, and then collect like terms, and I end up with a quadratic. So the next thing they want me to do is to figure out what is the maximum revenue they can expect and what session fee gives that maximum. Well, sure enough, if you think about this quadratic, it opens down, so its vertex is a maximum. So I'm going to go ahead and actually use my method of completing the square to find my vertex. So I pull out the negative 20. I find the number that completes the square. I throw out the negative, and then I clean things up. So I find my vertex is 5 and 4,500. Now, if I were to interpret this purely mathematically, it's telling me that I get a maximum of 4,500 when x is equal to 5. But let's put a little bit more into that sentence and let's talk about what is the maximum representing. Well, the students in the student council will have a maximum revenue of $4,500 when they, and we know that the x was the increments of change, so when they increase the price by $5. So when they asked us what would the price or what should the price be, remember it was $10 to begin with. And what we're suggesting is that we should change it by 5. So it's a total of $15. Okay, everybody, there you have it. That's how we rewrite the standard form of a quadratic function into the vertex form by completing the square. It's absolutely essential that you complete your homework on this one. It is a very new and a very interesting section. So do it carefully and be sure to bring any questions to class. Good luck, everybody.